In this problem, it says a rhombus has diagonals of length 10 and 20. The area of a circle inscribed in this rhombus is k pi. So we want to determine the value of k. So in a rhombus, the diagonals are perpendicular to each other. So this would be 5 and 5. This would be 10 and 10. Because not only are they perpendicular, but they bisect each other. So then after that, put in our circle. And so because this rhombus is symmetrical, we really only need to focus on 1/4 of it. So that way we can get up close and see what's going on. So we have 5, we have 10. Now if we use the Pythagorean theorem, 5 squared plus 10 squared equals c squared. So 25 plus 100 equals c squared, so 125 equals c squared. So square root of 125 equals c, which simplifies to 5 squared of 5. Now that's the outside, that's the hypotenuse. But what we're concerned with is this. And so what's going to happen is the radius is going to meet the hypotenuse at a right angle. And what's key about this is that it breaks this right triangle into similar other right triangles. So what we've got is we've got this triangle, 5, 10, and 5 squared of 5. But remember, other triangles share that same angle. And in particular, this one right here. So if I draw that one, it's going to be 5 and r. So what we've got is we've got two similar triangles, so that means we can set up a proportion. So 5 squared of 5 over 10 equals 5 over r. So we cross multiply. So 5 squared of 5r equals 50. And so we divide by 5. So square root of 5r equals 10. And then when we divide by square root of 5, we get 10 over square root of 5. So there's our radius. So the question asks, what is the area of this circle? So area is pi r squared. So pi times 1 times 10 over square root of 5. And that quantity is squared. So that's going to be 100 over 5. So that's going to be 20 pi. So we're concerned about the quantity attached to pi. And that number is 20. And there's our answer. And we're done.